Okay, so we are going to look at some formulas that will predict the behavior of lenses. Now you know ray diagrams. We're going to look at this particular ray diagram. Okay, and we're going to define a couple of distances. Distance u in centimeters or meters, as long as you're consistent, it doesn't matter. Distance u is the distance from the position of the object to the axis, the vertical axis of the converging lens. Okay, so that's our distance u. We also need to know distance v, which is again from the principal axis, the vertical axis, through the convex lens to the position of the projected image. Okay, so that's our distance v. And then we have our distance f, which is our focal length, which you should be familiar with. Okay, so what is the relationship between those three distances? Well, it's up here in the lens formula. 1 over v, okay, 1 over v plus 1 over u equals 1 over f. There are a few things that you have to take into consideration, okay, because there are situations such as when the object is very close to the lens, where we get a virtual image. Okay, so our u is the same, the position from the object to the lens, but our v now is in the same direction as u, and we need to account for that mathematically. There is a sign convention, and the sign convention is a real image is a positive one, and a vertical image is a negative one. So in this situation here, where we have a virtual image, v would have a minus sign. Again, I'll emphasize units must be consistent. So if you're using centimeters for one, you'd have to use centimeters for all three. Okay, now I would stop this video and I would practice using the exercises on Moodle first before you go on to the next formula. Okay, welcome back, and I hope you found those three questions easy. But now we're going to look at another relationship. We're going to look at something called the lateral magnification, or in this particular syllabus, it's the lineal magnification. Okay, so just to re-emphasize that, the lineal magnification, M, and you're asked to define it. So the definition would be the ratio of the height of the image to the height of the object. Okay, and the symbol is M, and of course there's no units because it's a ratio. So if we go back to our original diagram, we can see here that our image height, okay, would be this vertical height here, and the height of the object would be this height here. Now this would give us a ratio of heights, which in this particular situation, where you get a real image, might not be so useful, but for the second situation, for a virtual situation where the light is projected in the same direction, we have a magnifying effect. So what this does is it tells us by what factor the magnification will take place. So in this case, the ratio would be the height of the image to the height of the object. And you should actually get a number which is greater than 1. It can also be shown that, but the proof is not necessary, that the object lineal magnification can also be worked out by looking at the ratio of the v and u distance. And in fact, using the ratio of v over u, so if you go back to here, v over u, you actually get the same ratio. So the image distance over the object distance can also be used to find m. You may now continue with the worksheet and finish the rest of the questions.